So, so today we will be comparing and ordering fractions. A fraction is a number that expresses equal parts of a whole object or a set of objects. So here we have a piece of paper split into two equal parts. If we shade this half, we can see that the shaded part now represents 1 out of 2 equal parts. Similarly, for the set of objects, the pencils, if we take 2 of those pencils, we are left with a fraction that looks like 2 out of 4. 2 out of 4 is equal to 1/2. So we took 1/2 of those pencils. So now we will have another example of fractions. If we have a whole pie and the pie, so if we were to cut this pie, we would be left with 6 equal slices of pie. That would represent the fraction 6 out of 6. Now, if someone came along and ate one of those pieces of pie, we would be left with a fraction that reads 5 out of 6, because now a piece is missing. Next, we will be looking at fractions and ordering them so that they can fit on a number line. So here we have a number line that goes from 0 to 1, and then we have 3 fractions. So these 3 fractions represent 3 out of 4, 1/2, and 8 out of 8. In order to number these fractions on a number line, we first have to see how much is in the number line, like how many equal parts can we fit these already given fractions onto the number line. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Oops. So once we have figured out how our number line is divided, we can now begin to see how we can fit our given fractions onto our number line. So the 8 out of 8 is obviously 1, because 8 out of 8 is equal to 1. Next is 1/2, and 1/2 is equivalent to 6 out of 12, so we know that that one goes there. The last one, 3/4, we have to figure out the equivalent fraction for 3/4 on this number line. So we can figure out that 9 out of 12 is equal to 3/4. Next, we will be looking at how 2 fractions with the same numerator can be very different fractions, despite them having the same numerator. So here we have 2 fractions, 1 out of 6 and 1 out of 3. So if we shade this part, that is our fraction, 1 out of 6. We can clearly see 5 empty boxes remain. That would be 5 out of 6 remaining. For 1 out of 3, we can shade this box here, and we can clearly see 2 boxes not filled in, because that is our remainder, 2 out of 3. Finally, we will be demonstrating fractions in real-life context by using time and money. So, you're probably wondering how a clock can fit into fractions. But, as we can see, a clock can be divided up into 12 equal parts, 1 for each hour. Now, as you can see from some of these fractions, they are not simplified. So, if we simplify them, we are left with this. So, as we can see, a 1/4 hour, So, as we can see, a quarter hour would be something like this. That is a quarter of the whole clock. If we want a sixth of an hour, just go here. Similarly, for all other fractions, a half hour would be 2 here, and 5/6 of an hour would be 2 there. So as you can see, it is very easy to implement fractions into clocks and telling time. Next, we will demonstrate the use of fractions with money. So here we have a Canadian dollar, and if we wanted to split this dollar up into quarters, we would just take 4 quarters. Each of these represents 1/4. So in order to get a dollar, you need 4 of these. Similarly, if we divided this dollar up into tenths, we would have 10 dimes, because each one of these is equal to 1/10. And if we wanted to get a dollar, we would need 10 dimes. Similarly, the same concept can be applied to 5-cent coins. So, in order to get $1, we would need 20 5-cent coins. So each of these 5-cent coins are equal to 1/20th of a dollar. In that, you need 20 5-cent coins to get $1.